Hello and welcome to another geometry lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 4, Lesson 5 on constructing a perpendicular to a line. So we've been doing a lot of constructions lately, and even in the last lesson we saw how to construct a perpendicular to a line through a point that lies on the line. Today we're going to be pushing the perpendicularity a little bit more, including seeing how we can construct a line perpendicular to another line that passes through a point not on the line. Well, that was kind of wordy. Let's see what we're getting at. Now, perpendiculars from a point to a line. We've now learned how to construct a perpendicular bisector of a line segment and how to draw a perpendicular line through a point on a line. In this lesson, we will learn how to construct a perpendicular line to a line from a point not on the line, all right? In other words, if I've got a situation like this, I've got line M and I've got point A, right? I want to figure out how to construct that line. There's one line that passes through A that happens to be perpendicular to M. Now, this is an important construction for a variety of reasons, but one of the most important reasons is that the shortest distance from the point to the line is going to be the length of the perpendicular segment from the point to the line, right? Any other particular segment is going to end up being longer than that. If you will, it's sort of the hypotenuse of the right triangle, right? Now, in order to do that construction, we have to first review a very important concept and a construction that we saw quite a while ago. Let's talk about perpendicular bisectors. Perpendicular bisectors and equal distances. Recall, any point that lies an equal distance away from the endpoints of any line segment lies on the perpendicular bisector of that line segment. So if AC is equal to BC, then C lies on the perpendicular bisector of AB, i.e. line P. Okay, now I cannot oversell how important this idea is, right? The idea that if we can find a point that is the same distance away from one end of a line segment as it is from the other end of a line segment, then that point lies on the line segment's perpendicular bisector. So critical to understand this. It's going to be part of a lot of different constructions as we move forward, so make sure to get that idea down. Now, the first place that idea comes up is simply when we're trying to construct the perpendicular bisector of a segment. Now, we did this way back in Unit 1, so let's review it now. Exercise number 1. In this exercise, we will review how to construct the perpendicular bisector of segment AB. Letter A. Draw an arc above AB with a center at A that is more than half the length of AB. Draw an arc above AB with a center at B that has the same radius. Mark their intersection point as C. All right, so let's do that. So I'm going to take my compass and I'm going to bring it up and I'm going to put the pointed end at A and I'm going to extend the compass so that it is more than half the length of AB. And I'll kind of discuss why that is eventually. What I'm now going to do is I'm going to draw an arc with that particular radius somewhere up here. Then I'm going to flip my compass around, put the pointed end at B, and I'm going to draw another arc with exactly the same radius. Okay, and right now I'm going to mark that as point C. All right, great. Let's now take a look at letter B. Repeat the procedure below AB. The radius does not need to be the same one in A, but it can be. Mark this intersection as point D. Okay, so let's talk about this. I want to do exactly the same procedure I did here, except find a point down here. I can leave my compass to be the exact same radius, or I can change it. It doesn't matter, it just has to be more than half the length of that particular line segment. So let me bring it over here. I think I'm going to actually just leave it as the same length. All right, I just got to get my rotation here. All right, now I can move this. Oh, no, wrong direction. There we go. So I'm going to actually leave it as the same length. Again, it doesn't need to be. It can be a different length. All right, now I'm going to flip my compass around and bring it over to A. Okay, and make it again. All right, and this said to label that intersection point as point D. All right, and now my final piece of this construction, letter C. Draw a line through C and D. Why must C and D lie on the perpendicular bisector of AB? So let me just do that up here, and then we'll take a look at the picture that I have down there. So I am going to do this. I think I need to make my ruler a bit longer, but for me, that's easy enough. Oops, spoke too soon. Try it again. There we go, and that is the perpendicular bisector of AB. Now, because the arcs down here can be the same radii as the arcs up here, many times what people will do is put the tip of their compass at one of the 2 points and draw an arc that goes all the way through, and then switch it over to the other point, not changing the radius, and then draw an arc all the way through. So they'll oftentimes then get a picture that looks kind of more like this. Now, let's make sure that we understand why both C and D must lie in the perpendicular bisector of AB, and therefore when we connect them, right, we get the perpendicular bisector. Well, think about this for a minute, right? If we were to draw in this segment and this segment, right, because because point C lies on an arc that has the same radius from A as it does from B, these two lengths have to be the same. They have to, right? So C is equidistant from points A and B, so must lie on its perpendicular bisector. Likewise, right, B, or point D, also lies an equal distance from A and B, and if you haven't changed your radius length at all, it's the same as those two distances, so D lies equidistant from A and B. So what do I want to say here? Why must both points C and D lie in the perpendicular bisector of AB? The reason for that is because C and D lie equidistant from points A and B. And maybe I should be because both C and D lie equidistant from A and B. All right, now again, right, these two definitely have to be the same length, and these two definitely have to be the same length. But these two don't actually have to be the same length as these two, but in all practicality, they almost always are. The perpendicular bisector of a segment is a critical construction to know. It gets used all the time. For instance, well, actually, let me just, right now, the perpendicular bisector construction is likely the most important construction you learn. It pops up in all sorts of other constructions. So you could imagine a situation, right, where you're on, let's say, a state exam or something like that, and you see this problem. Exercise number 2. Construct the midpoint of EF shown below. Mark the point as point M. Right? Well, you're never going to be shown the midpoint construction because there isn't a midpoint construction, right? What there is a perpendicular bisector construction, which because it bisects the segment, it must pass through the midpoint of the segment. So what I'd like you to do is pause the video right now and construct the perpendicular bisector of segment ED, and wherever that intersects segment, I'm sorry, not ED, EF, wherever that intersects segment EF is the midpoint. Label that M. Pause the video now. All right, let's do it. So again, I'm going to kind of do I wouldn't call it the cheating method. I'm just going to do the easy method, which is to extend this more than half the distance of the segment. All right, and then I'm going to draw an arc that actually goes all the way like this. Now, without changing the length of my radius, I'm going to put my tip of my construction, my compass at F, draw the same arc. That guarantees that those two intersection points are equidistant from the end points of the line segment. Bye-bye. Bring this up, connect those 2 points. That now is the perpendicular bisector of the segment, which is really a means to an end, because now we know that's the midpoint, right? They could also say just construct a line that bisects the segment, right? There's a line that bisects the segment. It also happens to be perpendicular to the segment, but whatever, right? You know? So the perpendicular bisector is a very, very important construction. Very important construction. Can't even emphasize it enough. All right, now we can finally get into the new one, right? Perpendicular from a point to a line. Now that we've reviewed the perpendicular bisector construction, we are ready to learn how to construct a perpendicular from a point to a line. Let's take a look at exercise number 3. Let me move this out of the way. Given line M and point A, not on line M, do the following. Letter A, draw an arc with a center at A that intersects line M twice. Label these intersection points B and C. All right, this is a little tricky, okay? So what I want to do is I want to take my compass, okay? And I want to put the point on A. Now this is going to be the tricky part. Actually, let me rotate this down a little bit some. I want to put the point on A, and I want to draw an arc that is going to pass through the line that I'm given twice. That can be tricky, okay? So what I often do is I do something like this, and then without actually drawing the line yet, I kind of rotate my compass to make sure it's going to intersect that line twice, and here it is. So then I draw my arc. Okay, now I'm going to just close that up. Excellent. And I'm going to label those 2 points B and C. Okay. Now, let's take a look at letter B. Explain why A must lie on the perpendicular bisector of segment BC. That seems weird. A, this point that was just on our paper to begin with, must be on the perpendicular bisector of the segment that starts at B and goes to C. I want to be very clear about what I'm getting at here, okay? Point A must lie on the perpendicular bisector of that segment. Why is that? Pause the video now and see if you can answer that question. Well, we'll write it all down in a second, but just think about this, right? B and C lie on an arc that's centered at A. So AB and AC, being radii of that arc, must be the same length. And if AB and AC are the same length, then A lies equidistant from points B and C, which means it must be on the perpendicular bisector of segment BC, right? That's a lot to get down, but let's kind of get it there, right? So B and C lie on an arc centered at A, so A is equidistant from B and C. So what we really do, this is kind of cool. What we did by drawing this arc is this is fun, we created a segment, right, where the point in question must lie on the perpendicular bisector of that segment. Okay, you probably almost know what's coming next, letter C. Construct the perpendicular bisector of segment BC. This should pass through point A since it lies in the perpendicular bisector. So remember, we just did this. We literally just reviewed how to construct the perpendicular bisector of a segment. So for a moment, don't worry about A. Let's construct the perpendicular bisector of BC. All right, la-di-da. I'm not going to even think. I'm going to pretend point A is not even there. All right, I'm going to come over here. I'm going to put the tip of my compass on point B. I'm going to open it up so it's longer than half of the length of BC. I'm now going to draw an arc. I think I'll just do the cheap method, draw an arc that kind of goes above and below. Switch, but keep the length the same. Again, put it now on C, right? And then draw that. And now that's it for my compass. Move this away, right? Now I'm going to use my ruler to connect the two intersection points, right? The one up here and the one down there. And look at that. I can't do it any better than that, literally, right? This line that I just drew is the perpendicular bisector of BC. But because we made B and C points that were equidistant from the point that we actually care about, A, when I draw the perpendicular bisector of BC, it must by default go through A. Now, I wanted to point out one thing real quick before we move on and get some practice with this construction, right? We actually have almost more points than we need, right? We only need 2 points to really determine where the line is. All right, and we actually have 3, right? We've got this one, we've got point A, and we've got the one down here. So in theory, I really could have just drawn the 2 arcs intersecting down here, or even, if you're gutsy, just draw the 2 up here and then use point A as my second point. And I'll kind of show you how that's done as we move forward, okay? But that is how we construct a line perpendicular to another line that passes through a given point, not on the line. Whew, that's very wordy. All right, let's take a look at exercise number 4 and get some practice on this. Construct a line perpendicular to the one given that passes through the marked point given. Okay, great. So again, let's do this one together since this is a brand new thing. All right, I'm walking you through all the ideas. So the first thing I want to do is I want to bring my compass up and put the point put the pointed part of the compass at the point in question. All right, I now need to make this thing a good size so that it's going to pass through that line segment twice. That does it, but I think I'm going to make it just a little bit wider. That's going to pass through once there. Oh, I like that. I like to have the segment as wide as I can possibly get it. All right, so there it is. Now again, the cool thing now is that segment, right, the segment that goes from this point to this point, right, E must lie on the perpendicular bisector of that segment. So I'm going to construct the perpendicular bisector of that segment. So I'm going to come over here, and I'm going to extend my compass so that it's more than half the length of that segment. Now, I know that E lies on the perpendicular bisector. I really just need to find another point that lies on the perpendicular bisector. So this time I'm just going to draw an arc below. And it doesn't, you could do the full thing. You could totally draw an arc that's both above and below. But at this point, the great thing is that E and that intersection point both must lie on the perpendicular bisector of that segment that goes between the 2 blue points. And so now I can simply just draw a line that passes through E and through that intersection point. Again, I want to emphasize something. If you decide to bring these 2 arcs all the way up here and all the way up here and find that second intersection point up here and draw that line, that's completely okay. It's just a little bit more work than you have to do. And you know, I hate doing more work than I have to do, so I decided to just make this one intersection point and then use point E because I know it lies on the perpendicular bisector of the segment that goes from here to here. All right. This is really kind of a cool gimmick, you know, the idea that we somehow create a segment along this line that C or whatever point it is lies on the perpendicular bisector of it. So see if you can construct a line now that passes through C that is perpendicular to line R. All right, let's do it. I'm going to bring my compass over here. This is the hardest part for me. All right, I'm going to extend my compass out. I want to make sure that it's going to intersect that line a couple times. Okay, there's good. That's good. Yep. Yeah, I like that. That's going to work. All right, so, my pencil apparently is so dull it's not writing anymore. There we go. All right, so now I've created this segment that C must be, on its perpendicular bisector. So now I just have to create the perpendicular bisector of that segment. All right, I'm going to come in here. I'm going to draw an arc from that point. Then come down here, switch, and draw an arc from this point. Hopefully. Nope. There it is. I always find that very strange when my electronic compass doesn't write. And now I just need to have a line that goes through that and that intersection point, and that is right there, or almost right there. All right, and that's it. It's so cool, right? Because this construction really combines, right, our perpendicular bisector construction with just creating a segment, right, along the line. So cool, right? When we draw that original arc, what we're trying to do is just create a segment that we know the point in question is equidistant, right? That distance and that distance are the same length, and therefore, right, it's an isosceles triangle, point C must lie on its perpendicular bisector. We just have to find another point that lies on its perpendicular bisector, and we do that by, right, finding a point down here that it's also equidistant from these 2 points, and then draw a line through. All right, let's do one last construction, then we'll wrap this up. Exercise number 5. Construct the altitude of triangle MNP from point M to side NP. All right, well, this is critical because you have to know what the term altitude means, right? The altitude of a triangle, right, is simply a line or line segment that is drawn from one vertex of the triangle, in this case M, perpendicular to the other side, in this case NP, right? So I want to do exactly what I just did, except, right, I kind of need to ignore these, right? I'm doing the same construction we just did, right, where I want to construct a point that is, a line, sorry, that passes through M that is perpendicular to NP, all right? All these lines are doing is just kind of like making it harder for me, all right? Pause the video now and see if you can do that construction one more time. All right, well, I'm going to get rid of the scribbles. I just wanted to be very clear about the fact that they themselves are irrelevant. I'm going to start this exactly the way I started my other ones. I'm going to put the tip of my compass at point M, and now I want a line segment. Oh, that's actually pretty good. A line segment that is going to intersect PN twice. And there, not bad, not bad. Okay. So now I've got that segment, right, along PN that I'm going to perpendicularly bisect. So let's do that. Let me just kind of set this up, get my compass to be longer than half of that length. So now maybe I'll bring it down like this, switch, bring it over here, bring it down like that. X marks the spot, move this out of here. And now I just need to draw a line through M and that point, and then I'll have my altitude. All right, great. I want to even throw the little right angle symbol in there, just so we can see it. Of course, altitudes are important because if I wanted to know the area of this triangle, right, I would want to take the base, PN, multiply its length by the length of the segment that goes from M down to PN, and then divide by 2, right? Base times height divided by 2. Okay, so again, sometimes we do these constructions just straight up, okay, you know, draw the perpendicular line that passes through this point and is perpendicular to this line, right? Other times, we have to know that that's what we're doing based on the terminology in the problem itself. All right, let's wrap this up. So today it was all about perpendicular lines all the time. And we started with the idea of just how do you construct a perpendicular bisector? Better yet, we reviewed that construction because we had seen it previously. And of course, the essential idea that in order to even find the perpendicular bisector of a segment, we need to find 2 points that are equidistant from the endpoints of that segment. Once we had that particular construction reviewed, we could then use it to construct a line that passes through a point that's perpendicular to a line that that point doesn't lie on, right? So those two are important constructions. That second one, of course, can come up when we do something like constructing an altitude of a triangle, and it's going to come up in another location where we try to find what's known as the orthocenter of a triangle. Very, very fun term. Anyway, more on that later. For now, I just want to thank you for joining me for another geometry lesson by eMath Instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.